Do you need to share files between the Linux system on the network? Stay tuned to learn how to build an NFS file server.
You're watching IT Pro TV.
Welcome back for more LPIC 2. In this episode, we're going to talk about building a file server with NFS. So, Don, what knowledge are you going to impart on us today?
Well, we're going to focus on the server piece. We'll do the client side in another episode, but we're going to focus on building an NFS server. So we'll start off with what NFS is and some of the things we need to know to get it ready. We'll see how to install NFS onto a Linux server, and then we'll create a couple of folders to be able to publish out and make available on the network. So by the end of the episode, we will have created an NFS server.
So why would we use NFS over other protocols like SMB?
Sure. So there's a lot of options that are out there. SMB, or Server Message Block, is a really popular one in the Windows world. They have a kind of open standards version of it called CIFS, C-I-F-S, which is the Common Internetwork File Sharing, I think CIFS stands for. Anyhow, whatever. It's just another standard that's out there. There's FTP, right? SFTP and all of those. There's a ton of choices for how you want to copy files over the network. But NFS is pretty popular in certain areas, certain scenarios, all right? The main thing about NFS is that it's been around a long, long time. It was developed back in the 1980s, so it's a very old, very mature protocol. The current version of NFS is actually NFS version 4, but NFS version 4 is not very popular. You'll see most people still run version 3, and that's because when people run NFS, they're usually looking for compatibility. NFS works on all Linux and Unix boxes. It works in Mac OS, and they even have an NFS client built into Windows. So regardless of what your operating system is, you can connect to a network share that's published in NFS. It's not very feature rich. It doesn't have a ton of bells and whistles to it, but if you just need a file server that's reliable and stable, NFS really does do a good job of that. You can bring it up in just a handful of commands. We'll see that right here in this episode, and be sharing files within moments.
So what do we need to do to get NFS installed on our system?
Well, on some Linux systems, it's installed by default, but not many. Usually they'll have the NFS client tools installed by default, but not the server. And that's actually a good thing because the NFS server has evolved a little bit, especially recently. For a long time, the NFS server had to run in user space, and so it had kind of strange access that made it difficult to secure. Newer systems will use NFS running as a kernel add-on. So it actually runs in kernel space, which gives it a little bit more stability, reliability, and we can take some advanced controls into it. If you're using things like SE Linux or AppArmor for extra security, it was really difficult to use that with NFS before, but in the kernel space, you can actually do that. So on most systems, we will actually have to install the NFS server piece. Now, if you're on a Red Hat RHEL system or CentOS, one of those, in those scenarios, you'll usually have to install it, and the package will usually be called NFS-server or NFS-utils, kind of depends on which distro. If you're on a Debian-based system like Ubuntu or Mint, Kali, any of those, then it's usually called the NFS-kernel-server. That's what we'll need to get installed to get NFS up and going. So I'll take my Ubuntu box. So I'm on Ubuntu 20.04, and I'm just going to say sudo apt install NFS-kernel-server. And so it's going to go and locate that so it finds it, and it's going to give me a list of all the different packages that need to be installed. We'll see things like key utils. It's used to generate key files. This is an encrypted session, right? So, well, let me back that up. Encryption is optional in NFS. NFS doesn't do encryption by default, but we have the ability to use some of that. And so you'll see some of the packages that are providing that. You'll see a lot of RPC, remote procedure call stuff like RPC bind, NFS common, but the NFS kernel server, that's the main one that we want. I'll just say yes to that, and it's going to let it install. And then once it's installed, I just need to make sure the service turns on. Now, in Ubuntu 20.04, it's actually going to turn the service on for me, but not on every distro, so you might have to turn it on yourself. And you can do that by saying sudo systemctl enable. Enable is going to tell it I want it to run at startup. And then -- now, I want it to run right now also. And then the name, which was NFS-kernel-server, like that. And that's going to fire that up. If we see any errors, we know we'll need to go and look into that. But otherwise, mine came up. And there's one other one I'm going to run real quick, which is just sudo systemctl enable -- now RPC bind. And that's going to start it up as well. RPC bind is usually enabled on a system, so I'm not too worried about it. But just to be safe, I usually go ahead and manually start it.
So what is RPC bind?
All right, so I mentioned RPC is a remote procedure call, right? NFS is built using RPC libraries. So when it talks over the network, these are remote procedure calls that you're performing. And RPC bind is what allows it to connect to a port, a TCP socket, so that other systems can connect. It's going to bind this service to a network port, and that's going to allow for communications. NFS version 1, 2, 3, they require RPC bind to work. We've got to have it. I mentioned that NFS version 3 is the most popular. You're usually going to need RPC bind. If you're doing NFS version 4, you actually don't need RPC bind. NFS version 4 uses something different, which is also what broke its compatibility with a lot of systems. That's why NFS version 4 is not as popular. NFS 4 adds some neat things like encryption and user authentication and things of that nature that make it really flashy, really modern and new, but usually we rely on NFS for compatibility, and that's why we end up with version 3. On the exam, they want you to be familiar with version 4, but they want you to be able to implement version 3, and it kind of shows how that popularity is. But that's basically what RPC bind does. It's providing that way for the service to bind to a port. NFS uses a number of different ports, makes it a little bit tricky to open it up on firewalls, but RPC bind is what's going to manage that.
And now that we're running NFS, are we automatically sharing our file system?
We're not. Nope. So as it stands, our system is running NFS, but we're not sharing anything. So even though I started the service, it's not doing it. And so we would actually have to go in and tell it to send some stuff out. So let's do that. What you'll find is there's really just two pieces to sharing out a folder. The first piece might seem kind of obvious, but we need to create some folders somewhere to be able to share out. A common place for people to put these is in the /share folder or /export. In NFS, they call them exports when you're exporting a folder to be available on the network. Personally, I usually stick them in the SRV folder because that's what SRV is designed for. It's for your services to store data and documents. So I'm going to go into SRV, and I'll just create a folder in here. I'll do sudo mkdir nfs. So I'm creating that NFS folder, and then I'll create a couple of folders in here. I'll do a sudo mkdir files, and I'll create another one called reports. So I've got two folders here, one called files, one called reports. These are the ones that I want to share out to people. Now, when people go to access these files, they have to have permission to write to them. Well, if I look at the permissions on those folders by default, I can see everyone's getting read, write, and execute. Everybody is also getting, or not everyone, sorry, the owner is getting read, write, and execute. Everybody is just getting read and execute. So if I'm going to share these folders out read only, default permissions are fine. I can leave them that way. But if I want people to be able to write to the files folder, I'm going to need to grant that permission. So I'll do a quick sudo chmod o+w. So for other users or anybody who's not the owner or the group, I'm going to add the write permission, and I'll do that to files. And now when I take a quick look, I can see that files has read and write assigned to it. And it lights up green, just kind of warning me because it also has execute permissions on it. Well, I need execute permissions on the folder so that people can navigate into it. I don't want that necessarily inside of it. So just a warning there so we know about it. But now I've got my permissions set. The folders are created. I just need to tell NFS to share these out. And we do that by modifying its configuration, which is stored inside of /etc/exports. So I'll do sudo edit /etc/exports. And when you look in there, everything should be commented out, right? And here's where we tell it what we want to advertise. And there's a slightly different syntax depending on whether we're running NFS version 3 or NFS version 4. The system defaults to NFS version 3, so we can just go and drop our folders right in here. I've got two folders, /srv/nfs/files and /srv/nfs/reports. Those are my two files. Technically, that's all I need to do. I can stop right there, restart NFS, and those folders will be shared out, but I'll get some errors in my logs. And that's because there's certain options we need to provide. And the options tell it various things that we need it to do. So normally what I'll do as a default is I'll come in and just put something like this. I'll say star sync, comma, no underscore subtree underscore check. That's kind of like the minimum set of options. And so I'll punch these in here, and that's going to make sure that I don't get any errors in my logs when the folder starts. So I can put that in. I'll go ahead and save that file, and I'll do a quick, let's see, sudo. Actually, I'll tell NFS to reload the folder list by saying sudo export fs -r. That's going to tell it to reload its configuration. And I can run -v to verify, and there it's going to show me those files. If I hadn't put those options in, I'd get some errors right now. But since I did, comes up clean, and there we go. And as a, I don't know, we don't necessarily have to, but I'm going to go ahead and restart NFS just to make sure that it's fully loaded, all of that, by doing systemctl restart nfs-kernel-server. That's going to restart that and make sure that everything's loaded nice and fresh. And now I've got an NFS server.
And when might we want to change the default NFS options?
There's a few scenarios. We're going to do an episode on controlling access, and so there's some stuff there that we would change those options for. For us, let me go back into that file real quick. So what I basically said here with these options, that star, the star means any computer is allowed to connect, right? So I could filter based on IP or host name or whatever. I'm not. I just put star. Anybody can connect. Then I said sync. Sync says I want to do synchronous writing. So if somebody writes a file, I am writing it on the back end at the same time. And they're not allowed to write another file until the first file completes 100%. So I got to finish writing it to disk before I allow them to write another file, right? That hurts performance a bit. So if I want to speed things up, I could come in and say async. Async says they can write a file, and while I'm still writing it to disk, maybe I've got it entirely in RAM, but I haven't written it to disk yet, I'll tell them it's okay to move on to the next file, right? That speeds things up, but if there's a power outage, I told them the file was done, and I hadn't actually written it all to disk yet, we could lose data. So sync is more stable, more reliable, but it's slower. Async is faster, but it's a little less reliable. So that's a choice that you have to make. Same thing with no subtree check. The subtree check says anytime somebody accesses a file, I need to, 1, make sure it's published in NFS, and 2, make sure they have permissions in the file system. If subtree check is turned on, anytime they go to touch a file, it's going to do a check first to make sure they've got permissions. Well, that slows things down. I could just say don't do the check, and now it's going to try and write to the file, and guess what happens if they don't have permission? They just get blocked. Right? It didn't really hurt anything, but they get a different error, and that causes some problems in applications. So a subtree check is more compatible, but slower. No subtree check is faster, but can cause some problems in some applications. It's a choice that we have to make. What I put here, these are pretty standard. It's up to you how you want to configure yours, but these are kind of the defaults. And on some systems, you don't even have to put these, just an assumed default. And you kind of saw that when I did the export fs-v, that see how there's a bunch of other options that are in there? These are things that it's assuming that are defaults and throwing them in there. We might need to override some of these. That's when we would change our options.
And once the NFS server loads that new configuration, are clients ready to connect?
Probably. I have to say probably because you might be running a firewall on your system. I actually don't know if I am or not. Let's see. I'll do a quick sudo UFW status. I am. Okay. So if you've got a firewall in place, they might not be able to connect. NFS uses a number of different ports, and they've got to be available to connect. So I'll need to open that up through my firewall. Whatever firewall you're using, you'll need to punch that in. NFS is very mature. So usually it's got a shortcut you can use. Like with UFW, it's really easy. I can just say sudo UFW allow NFS, and that's it. It adds the rule, and I'm done. I don't have to do anything else. I could go a little more specific if I wanted and say, like, maybe I just want my local network. So I could say sudo UFW allow from 10.0.222.0/24. So that's my local network to any port NFS, like that. And that would authorize just the local network to be able to get to that particular port. And if I do a sudo UFW status now, I can see those entries that were put in. Here's the one where I just used the NFW alias, which opened up port 2049. And then here's the one where I was a little bit more specific. So it's showing 2049, but just for that local network.
Well, this has been a great intro to NFS, and we've got more coming up, as I understand. But we talked a little bit about some of the benefits of using NFS as opposed to other protocols. We talked about how to install it. We talked about some other things like file sharing as well. But like I said, stay tuned because we've got more episodes on NFS coming up, so stick around.
Thank you for watching IT Pro TV.
If you're looking to restrict who can access your NFS server and limit what they can do, stay tuned. We'll show you how.
You're watching IT Pro TV.
welcome back. If you've been following along with us, you know that in the previous episode, we started talking about NFS. And in this episode, we're going to continue that conversation. So can you kind of give us like the 10,000-foot view of what we're going to talk about?
Sure. We'll talk about some of the ways that we control access to NFS through things like authentication, some of the export options when we set up a shared folder, and some of the other various ways of doing IP restrictions and things to limit who's allowed to connect to your NFS server and then gain access to the files that you publish.
You mentioned NFS authentication. So does that use standard Linux user accounts?
You know, NFS is a little bit weird when it comes to authentication because it technically, like if you look at NFS version 2 and version 3, it doesn't have authentication built into it at all. It's expecting you to be using authentication that's a part of Linux. So when you set up your file system and you set up file permissions on a folder, you've got users and groups, it's expecting that to all just work and already be there. But that's not always the case. Like when you have a Windows user connecting to an NFS share, they're not using a standard Linux or Unix user account. So they don't map up correctly and things kind of go crazy. And that's why NFS version 4 introduced a better mechanism for handling that. So NFS version 4 supports the GSS API, and that's the Generic Security Service Application Programming Interface, or API. And that allows it to support things like Kerberos, Open LDAP, whatever it is, any other type of authentication mechanism you have on the back end, the GSS API, it can handle that. Well, in NFS version 3, you didn't have support for that. So in NFS version 3, it just assumed that, hey, when somebody connects to a server, their user ID is going to map to a local user ID, right? Like here, let me show you my Ubuntu box. So I'm logged in right now, and if I do a who am I can see I'm DPZ. And if I type ID, I can see my user ID. My user ID is 1000. Well, when I connect over the network, if my user ID says 1000, then the NFS server is going to look here and see this 1000 is DPZ, and it's going to assume that's me. And then if I have the file permissions and so on, it'll let me in, let me access things. Here's the problem though. 1000 is the default user ID for Ubuntu. So if I take 500 Ubuntu laptops and give them out to 500 different people and they have 500 different accounts, they're all user ID 1000. And NFS will believe that. It'll think it's all the same person accessing. And so NFS is not really reliable for authentication by itself. We need to use some kind of centralized directory to be able to do that. If we used Open LDAP, Free IPA, even Microsoft's Active Directory, right? It's a Kerberos, not Kerberos, it's a LDAP-based directory service. So you can use those, and that's going to ensure that no two people have the same user ID. So I might be user ID 1000, but Sophie would be 1001, 1002, and so on as we add more and more users. And now we don't have duplicates because there's a central directory handling it. So in the Linux world, if you have a centralized directory, NFS will leverage that for the authentication piece. If you don't have a centralized directory, then you cannot rely on NFS for authentication, and that's when you're going to need to restrict access some other way. And there's a number of other ways to go about it, but we just can't rely on what's built into NFS.
So since NFS doesn't really know who the users are, then how can we restrict them?
Well, the most common way is to restrict based on IP address. So we know the IP addresses that computers in our network have, and so we can control their ability to connect via that address. But there's a few other things we can do to help kind of control access. And I almost touched on one in the last episode, which is when we create a shared folder in NFS, there's options that we can specify. And some of those options let us restrict the type of access that we've got. Let me show you here. I'll edit my file. I'll do a sudo edit /etc/exports. And here I can see the two folders that I shared out in the other episode. Well, for the options, I just did sync and no subtree check, right? So we talked about those and what they do. But there's other options I could specify. For example, a lot of times you'll see right at the beginning where people put RW or RO like that. And what those stand for is read write and read only. Read write means if somebody connects to the share, they're allowed to read data as well as write data to the folder. Read only means they can only read. Now, this is on the NFS side. File permissions still apply. So if the file permissions say they're read only, it doesn't matter if I put RW here because the file system won't let them write. But the other way around actually is helpful. Maybe they do have write on the file system, but if I put RO here, when they connect via NFS, they will be limited to read only. Read-write is usually the default, and then RO, we add that to make it read-only. But the default is not always the same on different distros, so check yours. You can see it with the export fs command, kind of what the default is if I don't set these. Actually, on this system, I believe the default is read-only, so I would have to come in and designate RW to allow that type of access. But that's one way that we can restrict things. Another thing that's kind of useful here are what's called the squash options. When a user connects, their user ID is used to identify them. Well, in almost every Linux distro, the root user has a fixed user ID. So even on the user side, if we're using OpenLDAP or whatever to make sure nobody has a duplicate user ID, the root user is still going to have a duplicate ID because they're not in OpenLDAP, right? And so let me get another tab going here. So this is my laptop. So if I do a sudo who am I, you can see I'm root. And if I do a sudo ID, I can see that root has an ID of 0. Okay, well, that's Ubuntu's default. I think Red Hat actually defaults to 1. But either way, if I had 500 Ubuntu boxes, they would all have user ID 0 for root. So that's one that we can't really fix the duplication on. So there's an option we can specify in here, which is root squash. And what that says is if somebody connects as the root user, as user ID 0 in this case, or 1, or whatever my root ID is set to, if they connect with that, squash them and treat them as an anonymous user. So now they won't have any more access than an anonymous user, which in most cases is none, and so they won't have access. You can also do, instead of root squash, you can do all squash, which says treat every user like an anonymous user. So now it's really limiting that access. If I just want to do an easy read-only type share, I could do that. Or we can say no root squash if I want to allow it. Root squash is the default on most systems, so we don't usually have to add it. But we just punch it in like that. That's just another feature that's available to help control that access. I'm going to turn root squash on just to limit that. But you'll see I've left my files share here as read-write, and my reports one as read-only. So again, kind of limiting that access.
Now that doesn't seem too terribly robust. So are we at least able to limit what machines connect to our NFS shares?
Yeah, so that's where the IPs kind of come in. And not just IPs, you can do host names as well. So for example, on files here, I might say Don Laptop. So now if a machine tries to connect and its host name is set to Don Laptop, it'll be allowed to connect. If its host name is set to anything else, it won't be able to connect, right? Well, I don't usually know the host names of systems on my network, so usually I'll switch to something like IP-based./I'll say 10.0.222.50, that's my laptop's IP. I want that one to connect. Or you could even say 10.0.222.0/24. I want that entire range to connect. And so now that subnet will be allowed to connect to my files share. So here's it. You can also do this through a firewall, right? Through firewall rules, same thing. But here I can do it in the export definition. So this will work regardless of which firewall I'm using.
And are there other methods available besides what you've already shown us for restricting access to NFS shares?
So for me, in real life land, we've kind of covered the ones that I would use. But on the exam, there's actually one more they mentioned that's important, even though it's significantly outdated, which is something called TCP wrappers. A lot of application servers that are built into Linux, they use some TCP libraries that have a function in them where we can filter what IPs are allowed to connect. And it's done through a simple text configuration file. Here, I just showed you how to configure it through NFS, but what if I wanted to configure other services like SSH and FTP and so on and have them be limited as well? Well, it would be done different for each one. So what TCP wrappers try to do is give you one consistent way to filter the IP addresses that are allowed to connect. And so it's done through this wrapper. It's the librap, L-I-B-W-R-A-P, librap library that provides this functionality. And when they compile things like the NFS server, they include that library, so that functionality is there. So it's actually built into the protocol. The kernel sees it, and it allows us to filter access to that service. Now, it's installed by default on every Linux distro that I've ever touched, and actually every Unix environment that I've ever touched. So it's pretty common that it's going to be there. And the configuration files are really easy. They're located in /etc, and you'll see maybe none, or maybe one, or maybe both of these, but hosts.allow and hosts.deny. These are files that allow us to define what hosts are allowed to connect or what hosts are denied to connect. Now, before I get in and actually do the configuration on them, I just want to mention something really important, which is that the allow file applies first and the deny file applies second. So if I allow something in the allow file, then it doesn't matter if it's denied in the denied file, that'll get ignored. So usually what people will do is they'll set their deny file to deny everybody. And then in their allow file, they'll just list the people they want to allow to connect. So that's usually how you do it. If you take your allow file and you allow everyone and then go and try do denies, they won't work. So we've got to do it in the right order. So let's take a look here. My system is a default Ubuntu install, so I haven't messed with it. So let's go see what I've got on this one. I'm taking a look in my /etc folder, and I'm looking for the files hosts.allow and host.deny, and I can see that I've got both of them sitting right there. All right. You might not have either of them on yours. They're just simple text files that you can edit. Let's take a look at host.allow. So I'll do a sudo edit host.allow, and mine is empty. Well, not totally empty, right? There's comments in here, but that all gets ignored. So all in all, there's nothing in here. So it's up to me to come in and put some information in here on who is allowed to connect and what I want them to do. Now, the syntax of the file is pretty simple. Basically, I start with what the service is. Well, this, I guess it does get a little bit tricky. You have to know the name of the service as it's running on your system. So for example, SSH is actually SSHD. It's the secure shell daemon. In the case of NFS, it's actually RPC bind. RPC bind is what's actually doing the network connections. And so I have to specify here RPC bind : and then who's allowed to connect, right? If I want everybody to connect, I could say RPC bind : all. That would allow everybody to connect. Or if I just want my local network, I could say 10.0.222.star, like that, and that's going to allow it. Now notice, it's not the subnet notation I used earlier, the /24. It's a wildcard. So you can use wildcards for host names and IPs and punch them in, and that'll limit it. If you look up top here, see how they've got like some host names listed, or you can do the individual IPs like I'm doing. So it's going to allow 10.0.222.anything to be able to connect because this is the allow file. And then if I go to the deny file, so hosts.deny, it's also empty. And then I can come in here and I can say RPC bind : all. That's going to deny everybody, including 10.0.222, but that doesn't matter because allow applies first. They're allowed in. This denies everyone else. This also takes effect immediately. So the moment I save that file, that takes effect right then. I don't have to reload anything. It's automatically read by the kernel. It monitors those files. So as of right now, only hosts whose IP address start with 10.0.222 can even see my NFS server. Better yet, get in and access a folder.
And this is all great information on NFS authentication. We were able to talk about how we can limit user permissions, and Don was even nice enough to show us a couple different ways of restricting client access. But we're not quite done with NFS yet, so stick around for more.
Thank you for watching IT Pro TV.
If you're on a Linux machine and need to connect to an NFS share, you're in luck. Stay tuned and get educated.
You're watching IT Pro TV.
Welcome back. I'm here again with Don, and if you've been enjoying learning about NFS so far, you are in luck because this episode is also about NFS. So what are we covering in this episode?
Well, we spent the last 2 episodes building up an NFS server. We never actually connected to it. So this time we're flipping over from the server side to the client side, and we're going to see what's involved. We'll get the NFS tools installed. We'll see how to connect up to an NFS server just temporarily, and then we'll see how to do a permanent connection if we need to mount something every time we boot up, all right here in this episode.
So if we want to connect to an NFS share, what do we need to install?
All right, so the first thing we need is the NFS client, and on a lot of distros it is installed by default, but not on every one, so we might have to install it. The package name for it is usually NFS-common, so we need to install that. If you've installed NFS utils or the NFS server, it's likely already installed the client piece, so you probably already have it, but it doesn't hurt to check. I'll take my system, and actually I'm on my server here. Let me switch over to my laptop, and on my laptop I will do a quick sudo apt install nfs-common, and we'll get that installed. Now, it might bring a few other things along with it. Looking at it here, I can see it's bringing in libtirpc, NFS common, RPC bind, right? A couple of different pieces there. NFS common and RPC bind, those are the two important ones if we're connecting to NFS version 2 or version 3 shares. If I was connecting to NFS version 4, I wouldn't need that RPC bind piece. It's going to install it regardless. We just don't necessarily need it. Once that's installed, I've got the client. I've got the tools to connect, but I do need to start up RPC bind, which is probably not running by default. So I'll do a quick sudo systemctl enable -- now RPC bind. That's going to turn that one on and get it up and running. RPC bind is what's going to actually negotiate the port connection to the server. And so that'll establish a session, and then NFS will run over that session. So RPC bind is a very important piece. We saw that on the server side.
So do we have to configure any settings on the client before we can use it?
A lot of times you don't. That it's just ready to go. The biggest thing that I encounter is usually firewalls. If you've got a firewall on your client, that might be blocking RPC in the way that it builds its connections up. If you got a firewall on the server, it could be blocking you as well. So you might need to do some tweaking there. But otherwise, the client typically just works. So on mine, like let's say for example, like I was having a problem with the firewall, right? So I was worried about being able to connect. Well, here on the client, I could just say sudo ufw allow NFS. And I could even filter that down like we saw in the server episodes to really specify just that one server, just to make sure that I'm able to connect to it. So we can punch that in if need be. But for most people, you won't even have to do that you're just ready to connect. And an easy way to test that is to use the show mount command. Show mount will let you see NFS shares that are on the network. If you just run show mount by itself, well, that's going to look for mounts on your own system. I'm not on the server, so that's not going to help. So I need to say -e and then point to a server. I'll point to mine, which is 10.0.222.51. And when I run that, if it connects, then you should get a list of all of the shared folders that are available on the server. And I can see the reports folder and the files folder, and they both have asterisks by them, which means any IP address can connect. So I don't have mine limited right now so that I can connect, but that's the list. If I don't get the list back, or if the show mount command freezes and sits there, that's usually an indicator that there's some kind of firewall in between you and the other side, or something else. Maybe the RPC bind service isn't running. You might need to start or restart the RPC bind service to get it going. But assuming you can see that list, your client's ready to go. You can reach out and connect to NFS shares using it.
So how do we mount a shared folder so that we can use it?
All right, there's two ways to do it. So there's a temporary way and a permanent way. Temporary way is if I just need to get at something for a little while, and we can use the mount command to do that. The mount command you're already familiar with because we can mount hard drives, USB keys with it, other types of file shares you can use mount with. But with NFS shares, it's really not much different. The way we do it is, first off, we need a folder to mount to. So I'm going to go into my /mnt folder, which is empty, and I'm going to make two folders in here. I'll say sudo mkdir files and reports. And so if I take a look, I just created two folders, files and reports, and I'm going to mount those NFS shares to these particular folders. So to do that, I just say sudo mount. And I do have to specify a file system. So normally the mount command will automatically detect a file system. But when you're going over the network, it doesn't do so well, right? The file system's kind of hidden from it. So we have to say -t, so it knows the type, and the type is going to be NFS. So -t NFS. And then the server, in my case, 10.0.222.51, colon, and then the folder I want to mount. Now here's where it gets a little bit tricky. I know the folder is called reports. But when I use the show mount command, see how I got /srv/nfs/reports? It's the full path on the server that I need to specify here. So that's what I'm going to do. So it'll be the server's IP or hostname, colon, followed by the full path to the folder. Then I specify the local path, and I'm going to put it in /mnt/reports like that. When I run that, it's going to reach out and it's going to mount to it. And then I can do the same thing for the files folder. I just need to change the names here. And so I'll put those in, and now it's going to mount to those. Once they're connected, I should be able to issue the mount command, and they'll show up in here. Well, there's actually going to be a lot of stuff, but it'll be the last two. These guys right here, I can see where they're mounted, and it shows their NFS type and so on. Mine's actually showing NFS version 4, even though I'm doing version 3 at this point. So we can't necessarily trust that, but we do see everything else is connected, and those files are now up, and I can browse and start to use them for whatever it is I want to use them for.
And will those NFS mounts persist even after a reboot?
They won't. So if I reboot right now, these go away. So this was temporary. This is all just stored as part of my session. The moment I log out, these go away. Right. So if this is something I need long term, then I need to put these in my fstab folder, so it'll be there every time I boot up. Now, I do have to be a little bit careful about that. So fstab, it really expects stuff to work. If something's in there and the server's offline, it can cause some errors during boot. It can get a little unhappy about it. So we want to be careful and really only put something in there if we absolutely need it. I like to test things before I throw them in fstab. I mounted the folders here, but I haven't really tested them. I haven't tried to write anything in them, so I could have problems and not know it yet. So I'm going to check that real quick before I get too far. I'm going to go into the files folder, and I'll just type touch test.txt, and okay, so I was able to write a file in there. So this did mount properly. I'm able to write. If I switch back over to my server, I should be able to go into /srv/nfs/files, and I can see test.txt. All right, so that one's working. If I test the other one, I'll do the same thing. I'll touch test.txt. Oh, I get an error on this one. So read-only file system. So when I brought this one into NFS, I published it with the RO option on. So it's read-only. I'm not allowed to write. So I do know it's working, though. I didn't get permission denied. I got read-only file system. So I know it's working. That's good. So now I feel confident about putting these over in my fstab file. So I'm going to edit that. I'll say sudo edit /etc/fstab. And, most of what you've got in here are physical hard drives. And so that's a little bit different than what I'm wanting to mount. I want to mount a virtual drive. And so for the mount, it's going to be similar to what we typed in the command line a moment ago. It's going to be the server's IP address or host name. I'll almost always use IP address here because when you're booting up, you don't know if you have connectivity to the DNS server yet. And so I don't want a DNS problem to stop me from being able to mount. So if I know the IP, I use the IP. And then colon and the path, which was /srv/nfs/files. And then where I want it to mount to, so mine's going to be /mnt/files. Then the file system, in my case that's NFS. And then the options. Now, don't confuse this with your NFS options. These are the file system table options, which are a little bit different. And so for a lot of people, they'll just type defaults, and that'll be the end of that, right? Or you might want to go and customize it based on whatever your needs are. If you want it to be read, write, and sync, and so on, you can specify that. But just know that these are not overriding what the NFS server has. The NFS server is going to take priority over whatever I put right here. So I'm just going to leave mine at the defaults. After that are the 2 bits on whether we allow backups with the dump command and whether or not we need to do error checking on the system. I'm going to put 0, 0. I don't want either, right? And the reason is I don't want to back up a remote file system, so that's going to be a 0. And if I can't connect to this disk, I don't need to run a file system check on it. I don't need to halt the boot process. I can just move on past it. So I'm going to stick a 0 on that one and just not have it checked for errors. So once that's there, that's what I need to have in place to be able to have this mount every time that I boot. And I could test it out a little more, like, we could save, I could unmount what I've already got mounted and then just run like a mount-a to have it try and mount all the file systems in the file system table, and it'll reconnect. Once that's up, now we know, hey, if I reboot, that file system is still going to be mounted and still accessible.
Now, is there an easy way to test if the mounts are working?
Well, there's a few different ways to test. What I did a moment ago was I wrote some files, right? That's kind of the easiest way, is just try and use it. And if it works, great, it works. If it doesn't, well, you got a problem. The only challenge with writing a file like I did is if something does go wrong, it doesn't really give you a lot of information back. All right. The show mount command is pretty handy. That one helps. The mount command itself, if I just run mount, I can look at the mount and the options on it. That can help to give me a little more information there. DF, so what we use to look at how much space is available on our disk, it'll actually work on the NFS share to show you the size and space. If that's not populated, you're not properly connected. So it should be able to see how much is available on those systems. So those are there. You can always try and write files using the touch command. And there's a few other things like let's say the system here said I was connected, but I wasn't able to write any files to it. Well, I would want to go check permissions on the server. And there's actually another neat command. Let me go over to the server, which is if we do sudo nfs stat, it's going to show us our NFS statistics. And with this, I can see information about how much activity is going on the NFS server. I can see how many calls are being made. If that's at a 0, if no calls are coming through, it's almost a guarantee that I've got a firewall or a TCP wrapper or something like that that's blocking access. People aren't even able to talk to the NFS server. But if these numbers are going up, if I see more calls happening, that lets me know that people are connected. It's probably not a network issue. It's probably a permissions issue, maybe file system permissions or authentication or something like that. But NFS stat is kind of nice to be able to see some of that. I don't believe that works on the client. Let me try it on the client real quick. Well, actually, I am seeing some statistics here on the client too. I don't know how meaningful that would be. It'd probably be more meaningful on the server side, but it just kind of lets you see what's going on and how active the system is. So a couple of different ways to test and verify. After this, if it's still not working, that's where I'll usually go into my syslog or the journal CTL, take a look in there and see if you can find some errors.
Well, now we know how to install NFS client tools in Linux. We know how to connect to an NFS share from the Linux command line. We know about mounting shared folders, and as Don just showed us, we know a couple of ways to test if those mounts are working as well. So we hope you've enjoyed this episode. Thanks so much for joining us, and stick around for more LPIC.
Thank you for watching IT Pro TV.
Did you know you can use Linux as a file server on a Windows network? Stay tuned and we'll show you how to set up Samba.
You're watching IT Pro TV.
Welcome back. I'm here with Dawn for more LPIC 2, and in this episode we're going to start our adventure into Samba. So can you give us kind of an overview of what we're going to start with today?
Sure. We'll kick things off with a little introduction to Samba for people who've never heard of it. Then we'll see how to get it installed and up on a system, and we'll look at a few little configuration items, things like letting it pass through a firewall, which are somewhat important. And by the end of the episode, we will have created a Samba server.
So you said you're going to give us an intro to Samba for people that have never heard of it, and that's me. So can you give us a little background on Samba?
All right, Samba has a bit of a storied history, right? So where this really all originates is from Windows servers. Windows servers share files and folders, printers, things of that nature, and Windows clients can connect to it. Now you might be asking yourself, why do we care about Windows computers if this is a Linux show? But the main reason is, in the business world, while you do see Linux on the majority of servers these days, you don't see it on desktops. Over 85% of desktops are running Microsoft Windows. That's the standard desktop operating system. Mac OS comes in next after that, and then Linux has this like 1% market share of desktops. So your end users are using Microsoft Windows, and they need to be able to connect to file shares. Well, that's not a new thing. It's been like that for decades. And back in the 1980s, IBM worked on a file sharing protocol that was called SMB, or Server Message Block. And this was designed for OS/2 and the early versions of Windows, and it evolved to, well, still be used today to be able to share folders and files and things like that. The problem was, though, that it was commercial software. So it was kind of locked away behind a paywall, and open source projects like Linux couldn't really make use of that. So several enterprising engineers decided to reverse engineer SMB, the protocol, and figure out how it worked. Once they figured out how it worked, they were able to build the Samba project. Let me just bring up their webpage here real quick. You can go to samba.org to be able to learn more about it. But basically, they reverse engineered SMB version 1 and SMB version 2 to be able to make it where Linux servers can act as that file server and share resources out to Windows machines, and they can connect to it. So kind of a neat thing. Well, Microsoft for a while just kind of ignored it, but in more recent years, they've accepted this, and so they've started they didn't open source SMB, but they have started releasing documentation on how the protocol works, because we now have Samba or SMB version 3. And so Samba is having to be updated for that. And so we have a kind of a duplicate standard that goes along with this. You'll hear me refer to SMB sharing, but you'll also hear me say CIFS or CIFS. And CIFS is the Common Internet File System. And that's the documented part that Microsoft has released out, and anybody can write software or networking stacks that are compatible with CIFS file shares. So Samba was able to adopt that, and now we can have Linux file servers with Windows clients connecting to them. And the Windows clients, they don't even really know they're connecting to a Linux file server. They think they're connecting to another Windows server, and so we can do this entirely with open source software.
So now that we've covered a little bit of what Samba is and some background on it, how do we go about getting it installed?
It's pretty easy to install. For most people, you just have to install one package. Let me just show you here. So I'm on an Ubuntu 20.04 server, and I'm just going to do a quick sudo apt list samba star, like that. So I'm pulling up all the Samba packages that are available. The main package that I care about is just called Samba, and that's it. That package contains the server and the client utilities all in one package. So it's the same package whether I'm on a server or a client, which is kind of nice. Now, I will say that some distros separate it out. That you'll have a Samba package, which is the server, and a Samba-tools package, which is designed for the client. That may happen in Debian-based systems. They don't separate them out like that. There is another package, though, which is, let me pull this one up, sudo apt list. I'll do sifs star this time. And so I've got a sifs utils package. Well, that has utilities that are designed for clients connecting. We'll need that later when we set up our client, but today I'm focused on the server, so we don't need that. So to get Samba installed and up and running, I just need to install that one server package. So I will do a sudo apt install Samba. Whoop, I'll spell it right because that helps a little bit. And you'll see all the different packages it's going to bring along. There's a lot of other packages that get brought in just for library support and so on. When I pulled up the list, let me scroll back up here, there's all these other ones like Samba-common, Samba-common-bin. Those are going to get installed as well because we need those binaries. But you'll see things like Samba-DSDB. Well, that's a directory service database, an open LDAP variant just for Samba. That is an optional piece. Many people won't use it. They'll just use the Linux user database, or they'll connect to an Active Directory or something else. So those are less common. VFS is a virtual file system. There's a lot of NAS, network attached storage devices, that make use of Samba, and they'll use that VFS because they'll have complex RAID arrays and other things that they're trying to hide from the software that they're running. So the VFS modules do that. But for most people, we're not going to need those. We just need the base Samba package. And so that's what mine's going to install. I'll say yes to that. It's a blazing 98 megabytes, so very small. That'll get installed pretty quick. And when that's done, I've effectively installed Samba. It's probably the most challenging thing I'll do today.
So from here, is Samba ready to go, or is there a little bit of assembly required?
Well, it's likely up and running, and so that's good. It does have a default configuration, but that default configuration does next to nothing. So it really does require a little extra work for us to get it going. But let's pretend for a moment. Even if it did have a perfect configuration and had everything set up the way we wanted, we still have the matter of letting our clients connect to it. And the odds are we're running a firewall that we're going to need to configure to allow Samba's traffic to come through. Now, Samba is built on top of emulating the SMB protocol, and the SMB protocol is fairly complex because of how old it is. It was designed at a time when networks were very chatty, when protocols didn't have encryption and authentication. It was really, really basic. And it's evolved over the years, and that shows in the ports that we have to open up in the firewall. Now, if your firewall software has an alias for Samba, that's the easiest way to allow it through. So you might be able to do something like this. Here on Ubuntu, I've got the UFW, or uncomplicated firewall. I can say sudo UFW allow, and then Samba. It has an alias for Samba, so it knows that technology, and it opens up the appropriate ports to allow that through. And if I do a sudo UFW status, I can just see that one entry right there for Samba. But if your firewall doesn't have an alias, then you're going to have to do it by hand. And there's a few different other rules we'll need to put in place because there's 4 different ports that get used when Samba is communicating. So I'm going to back out that rule that we just put in there. So I'm going to do a sudo UFW status numbered, and then we'll delete those 2 rules. I will delete number 4 and number 2. All right. So with those out, now I'm going to do them manually. So the first one will be sudo UFW allow, and I'm going to allow 137/UDP. All right. Samba, or SMB, uses port 137, and it uses UDP to be able to discover other people on the network. If I wanted to add a comment to this, this would be the NetBIOS name service. So this is used for discovery, finding other systems. When I browse to a file server, I type in the file server's name and we find it. That's the NetBIOS name service. If you've never heard of NetBIOS, well, that's actually a very old Intel protocol. It was used for the Intel LAN Manager project, and that's what became the networking stack in Microsoft Windows. So we've mentioned IBM, Intel, Microsoft. These companies, they're at each other's necks now, but back in the 80s, they were actually friends. And so they created a lot of interoperability and sold products to each other. So that's where we see this overlap. But that's the first port that gets used for discovery. Now, on older machines, when they'd go to start sharing files back and forth, that's where the NetBIOS datagram service would come in. And that's the next port that I need to open up. So I'm going to change this one. This one's going to be port 138 UDP, NetBIOS datagram service. All right, so now that one's opened up. However, after a certain time, the protocol needed to evolve. They went from SMB version 1 to version 2, ultimately to version 3, and Microsoft moved away from NetBIOS and replaced it with some of their newer technologies. And so we have a couple other protocols we have to allow. The next one is UFW allow 139 TCP. So I'm going to add that in. And this is SMB over NetBIOS. So I'll just type that in, SMB over NetBIOS. And this is being used for pre-Windows 2000 machines. So I'll just add a note. This is pre-Windows 2000 or 200. There we go, 2000. So prior to Windows 2000, we're talking about Windows 98, Windows 95, Windows 3.1. These are things that nobody runs anymore, right? They used TCP 139 for SMB over NetBIOS. So that was kind of the evolution there for those. But after Windows 2000, they switched to something completely different. And so I'm going to just update this rule. So this will be Windows 2000 and newer. For Windows 2000 and newer, they do SMB over TCP, not over NetBIOS. Transmission Control Protocol, or TCP/IP. That's the standard protocol stack for communicating these days. So this is what modern machines use, and it's done over port 445, right there. That set of 4 ports, that's what Samba uses. And so once we've opened that up, people will be able to connect to our server, and now if we had a good default configuration, we'd be in business.
So let's say I want to deviate from that default configuration. Where are the config files stored?
All right, the nice thing about Samba is almost everything is in one configuration file. If we go into /etc/samba and take a look at that folder, there's not much in there, right? And the main file I want is that smb.conf. That's the main configuration for Samba, and is usually the only file you'll need to edit. So I'm going to do a sudo edit /etc/samba/smb.conf. So that's going to pull up that configuration file. And what you'll find in here is that a lot of what's in here is commented out. So there's only a few options here that are actually turned on, and we can go through and modify those if we want. Common things that you'll modify are right here at the top, like the workgroup name. The default Windows workgroup name is workgroup. And if that's what you're using, like maybe at home, then that's fine, leave it. But if you're using a different workgroup name, you'll need to modify that. And then your server will actually identify that it is an Ubuntu server. Maybe you want to hide that. You could change that name and kind of modify those settings as well. And this is basically how this whole file is structured. Things that are lit up here are options that we can turn on, but watch out, some of them have a pound symbol at the beginning commenting them out, disabling them. So it's up to you just to change the options that you want to change. You might need to uncomment some lines to get the settings. But this is basically where the entire configuration for Samba resides.
Now, how would you go about troubleshooting Samba if the service didn't start?
All right, well, the number one problem that I run into with Samba is making a typo in the configuration file, right? So I make errors all the time. They happen right in here. I'm going to get out of the configuration. When you install Samba, it also installs a tool for testing the configuration. You can run sudo test parm, which is short for test parameters. It's going to read through the configuration and see if there's any errors. And so when I run that, it's going to go and look, and hopefully you'll get right here in the first 2 lines, these are the most important, load SMB config files, and then loaded services file OK. If you see anything else in that second line, then there's an error, and it'll tell you where the error is. You can go and you can kind of fix it. It's a basic check. You could still have things misconfigured, but at least that gives us a basic syntax check. So that's usually the first thing that I look for. And then when you press enter, it just outputs the whole configuration, which I don't necessarily need to see here. After that, we can troubleshoot this just like any other service. You can use systemctl. Some of my go-to commands, I'll do like sudo systemctl list-units -- failed. Show me any failed units on my system. And like if the Samba system has failed, I could pull up detailed information on that. If I do sudo systemctl status smbd, which is the server message block daemon, when I run that, I can see that it is active and running, but I can also see the log entries down here. And if there's any problems, I can go and kind of troubleshoot that. I can see mine's looking for some kind of app armor configuration that's missing. It's not stopping the server from working, but I might want to find out what that is and correct it. So that's easy enough. Other common errors you might see, Samba actually will not start if you don't have a host name set. Well, most Linux distros require you to set a host name, so it's not a problem, but there are a few distros that don't set a host name by default. You can check that real easy just by running hostname_ctl. If you run that, you should get something back, and you should have a static host name listed like I do. Mine's called Ubuntu-server. Yours is called, well, whatever you called it. If you don't have a host name, it's going to break things. You'll see that in the logs, and all you have to do is go and assign one. So I could say sudo hostname_ctl set-hostname followed by whatever I wanted to name my server with no spaces. It needs to be DNS compatible. Then I've got a host name, and the system will start back up. Any more failures? Again, just keep checking the logs, find out what the error is, and then go in and resolve it. It's a pretty straightforward process.
It's just that simple. And this
Sometimes.
Sometimes, we hope. Well, this has been a great introductory episode on Samba. We got to look at some background on Samba for those of us that didn't know what it was. We got to look at the installation process. We saw how to allow Samba through a firewall. And we looked at some troubleshooting issues as well, and some of the common issues that you might run into. But we're not done with Samba yet. We've got a lot more to go, so don't go away. We have more episodes on that coming up. Thanks for joining us, and we'll see you next time.
Thank you for watching IT Pro TV.
If you have a Samba server and you want to set up some custom shares, stay tuned because in this episode, we'll show you how.
You're watching IT Pro TV.
Welcome back. I'm here with Dawn for more LPIC, and if you've been following along so far, you know that we're talking about Samba, and in this episode, we're going to talk about configuring shared files with Samba. So what's the 10,000-foot view of what we're going to talk about?
All right, well, we brought up a Samba server in a previous episode, but it's not actually doing any work yet, so we needed to do something. And in this episode, we're going to see how to do that. We'll share out some home directories, printers, data folders, and just kind of look at some of the various other things that Samba is capable of as long as we take the time to configure it. So that's what we're going to do. We're going to learn how to configure it, and by the end of the episode, we will have a fully functional Samba server up and running.
Now, I think of Samba as a file server, but I guess you've mentioned printers, so what else can Samba share?
All right, well, folders are the number one thing, right? Samba, for most people, is just a file server. But the SMB protocol was designed to share just about anything. And so when Microsoft uses it, they very commonly share printers. Printers, most people don't think about it, but printers are just file shares that you create an image of what you're printing. That image is stored in a file, and that file is sent to a print spooler, which is just a folder, right? So it's the same thing as a shared folder, just tied to a different type of device. So it makes sense that Samba would be able to do file folders as well as printers. But it can actually do a few other really neat things like host names. Now, you might ask yourself, what do host names have to do with files? Not really anything. But if you're going to connect to a file server on the network, you have to find the file servers. So built into NetBIOS and SMB and all the different technology behind the scenes is a way to discover computers on the network. And that's done through what are called host lists. When you have SMB in place and you've got Samba servers, somebody has to become what's called the master browser. The master browser keeps a list of all the clients that are on the network, and Samba is able to share that list with any client. So when somebody comes up brand new on the network, they don't have to do a bunch of broadcasts and talk to everybody. They can just talk to the browser master. So a lot of that is built into Samba. It's actually a very incredibly powerful set of software. You can even make it emulate a Windows domain controller. So it can basically serve as your Active Directory server if you really want to go crazy. We're going to focus on data folders and printers in this episode, but just know that Samba can do a heck of a lot more.
So what is the most common configuration for a Samba file server?
All right, so the most common configuration is to share out individual directories for your users. And in the Linux and Unix world, we call those home directories. In the Windows world, they call them profiles. So each user likely has data that is theirs, and they don't want other users to have access. They just need a private place to store their information and know that they can get at it. Well, that configuration is so common that it's actually a part of the default that we find inside of Samba. Let me jump into Samba's default configuration here. I'm going to do a sudo edit /etc/samba/smb.conf. And there's a bunch of stuff in this file. Up here towards the top, it's kind of general server type settings. You'll see what interfaces we listen to and so on. But as you scroll down, eventually you'll get to the share section. Shares are easy to spot because their names are surrounded by square brackets. So I'm going to do, here, I'll just do a quick search. I'm going to look for the word homes, and there we go. So see how the word homes right there is written in square brackets, and it's commented out. It's got a little semicolon behind it, and that, or in front of it, which means that it's turned off. We're not actually sharing these home folders. But if we turn this on, Samba will automatically share out user home folders. Now, that doesn't mean anybody can get into my home folder. It means that I, D. Pizzette, can get into my folder, and if Sophie has an account, she can get into her folder, and if Bob has an account, he can get in his folder, and so on, right? So everybody has their own folder. Very easy for us to turn this on. In fact, it really does just boil down to getting rid of those semicolons. And so here we go. Now they're kind of turned on, but we'll usually customize a few options in here to make it function a little bit different. I'll give you a standard kind of configuration for me. Comment, that's just a name, a descriptor, right? So here it says home directories. You can change that to whatever, but home directories are what these are. Browsable. Browsable means when somebody browses to the server, can they see a list of all of these folders? In other words, could they get all of the usernames on my network? We don't normally want that. So I'm going to say no to that because users know their own username. They should be able to browse right to their folder because they already know the name. So I'll leave that alone. But some of the other things we might need to add, depending on the default configuration of our server, many Samba folders will default to being read-only. So you're not allowed to modify them. So I'm going to add a note that just says read-only equals no. I want to give people write access to their home folder. We might also do something like this: valid users equal, and then provide a user list. Now, if I was doing authentication somewhere else, I would just need to list out usernames. Or if I want to go a little more wild and just say, I want all users to be able to access this share, I can do a %s. And that's a variable stored in the system that says, if there's a Linux user account that matches that user, we'll let them in. So I have a D. Pizzette account. And so when I go to access, I'm a valid user that's going to be allowed in. Otherwise, I could do a slightly different list. We could also do things like restricting the domain name that the clients connect on, but that's not really a reliable parameter. Once we've got these basic settings in place, though, now the system knows who's allowed to connect, who's not allowed to connect, and they'll be able to get access to those folders. All I have to do is go and restart Samba so that it'll read these configuration changes, and now I'm sharing out the home folders.
Now, what about the printers that we talked about earlier? Are they enabled the same way?
Very, very similar, right? If you just want to share all the printers that are on your system, that's kind of the easiest configuration. Well, we have another share section in here for printers. In fact, I can probably just scroll down and find it. Actually, looking at it here, I duplicated that. I did valid users equals %s. They actually have a note down here, but there's a capital S, which would be domain name, not username. But if I keep going down, eventually I'll find printers. There it is. Printers are actually turned on by default. I didn't realize that. But I can see this one's got a comment. Browsable is set to no. Well, I'm going to set that one to yes. I want people to be able to browse and find the printers. Maybe somebody doesn't know the printer names. That's not uncommon. Printable equals yes. We want people to be able to print to it. Guessed okay. Do I want anonymous users to be able to print? Probably not. Then anybody connected to your network could start throwing junk jobs at your printer and run you out of toner and paper and things. Read only. Read only is set to yes. And here it's not referring to the print queue because up here we have printable yes. Read only means looking at the print jobs. So you could cancel print jobs if you were able to write to it. We'll usually leave that as read only yes to prevent that so that people can't go and delete other people's print jobs. But once these are set, any printer that's shared through cups or the common Unix printing service, any printer that's added to cups will now also be shared out by Samba. It'll be available on the network, and you'll even see down here where there's a printer driver share that goes along with it. We can take drivers for like Microsoft Windows and other OSs and throw them in that folder. And now when people connect, if they don't have the right driver, they can actually pull the driver right from our print server. That's not really needed in modern versions of Windows. Windows will just reach out and get it from the internet, but it does give you a little bit of control there. It's really designed a little more for legacy clients.
Now, so far, we've talked about sharing pre-existing things, things we might want to share that are already there. But what if we want to create something new, like a folder for an entire department?
Sure. And that's a really common scenario too, is people have their own home folders on their workstation, right? So maybe we don't want to worry about that. We want to create a central storage place for a team. So maybe my marketing team. I want the marketing team to have a central share where they can put all of their marketing assets, their images and ads and things like that. So I want to create a folder for that. Or maybe I want to go for the whole company, right? I'm just going to create a corporate storage folder. Well, for that, we just have to define a new share. And what most people will do is they'll just go to the very bottom of the file. So I'm all the way at the bottom now, and just add in that share. Adding it in is not hard, but there's a little bit of work I need to do before I add it in. I'm going to get out of this file, because if I'm going to share a folder out, I should probably have a folder first, right? So I need to go and create a folder for it. Now, you can technically put the folder wherever you want, but if you're running AppArmor or SE Linux, there's some restrictions on what Samba is allowed to read and write from. So you do have to be a little bit careful. You have to check your distro's documentation to find out what's allowed. And you can always customize AppArmor and SE Linux if you need to. But if you want a nice, safe place to store things, the SRV folder is usually the best place to do it. I'm going to go into /SRV, and looking in there, it's completely empty. I'm going to make a directory called Samba, and actually I'll have to sudo that to get it created. So I've created a Samba folder, and inside of Samba, now I can start creating folders in here, and these are the folders I'm going to share out with the protocol. So maybe I'll do a sudo make dir. Maybe I want to have a marketing folder, or a folder just called corp or reports or whatever it is. Remember, these are case sensitive. I want to do that corp folder. There's one for my entire company. But each directory that you create can be shared out individually and can have different permissions and different types of data. There's no limit to this. You can create as many folders as you want. But once we've got the folder in place, we do have to deal with some permissions. I've got that corporate folder. I want anybody in my company to be able to access that folder and read and write data to it. So we'll need to adjust a few things. First off, I need to create a group for corporate that everybody's going to be a member of. So I'll do a sudo group add corp. All right, so that's going to create a corporate group. Then I'm going to add myself to that group because I'm not in it. If I do an ID, I can see that I'm in the admin group and dpossed and so on. I need to add myself to that corp group. So I'll say sudo usermod -a-G. So I'm adding a secondary group, and that secondary group is corp, and I'm adding it to the dpossed account. All right. And then I can set a SMB password. When my user account accesses the system, I have a Linux account. Well, my Linux account has a password. Samba can use that password, or it can expect to get that password from somewhere else. In another episode, we'll see setting this up to use Active Directory. Well, here, if I just want to use a local password, but I don't want to give somebody a user account, I could just assign them an SMB password. We do that by saying sudo SMB passwd and then -a dpossed. So I'm adding the dpossed user from Linux into Samba and giving them a password to be able to use. I'm going to use the incredibly complex password 123. Best password on the planet. So now I've got that set. Now I've got my SMB password and I'm in that corporate group. So that's all good. Then I'm just going to change a few permissions. I'll do a sudo chmod 770. 770 is read, write, and execute for the owner and the group on the folder. And then everyone else is going to get 0, no access to this folder. So I'll do that. I'm going to throw a -R. The folder's empty, but if there was stuff already there, I would do a -R to make it recursive. And I'll point that at /SRV/Samba/corp. That's going to update those permissions. Then I'm going to change the owner. So I will do a sudo chown -R, and I'm going to change the owner to be dpossed:corp. Dpossed is me, so I'll be the owner, and then corp is the group. So anybody in the corp group will get read, write, and execute on this folder. So that gets those permissions kind of set. So that's the pre-work to sharing a folder out in Samba. Now I just need to tell Samba about it. So I'll do a sudo edit etc/samba/smb.conf. I'll go all the way to the bottom of the file, and I'm just going to add in square brackets, corp. And you can actually type whatever you want for the name. This is the name that people will see on the network when they're browsing. So if I wanted it to have a capital letter, I could just put it in there. But I usually make them match so I can keep it straight in my head. Otherwise, you get confused. So I'll just keep it the same. I can give it a comment. And so I'll just say that this is my corporate documents, like that. I will say path. This is the important part. This is going to be /srv/samba/corp. That's the folder that I'm sharing. Read only equals no. The default is read only equals yes. So I don't want it to be read only. So that's why I have to put no. You will see some examples on the internet where people say writable yes. There used to be two options: read only no, or read only yes, and writable yes. Well, those two conflict if you have both. And so they've deprecated writable. And now it's either read only no or read only yes, but you'll still see a lot of examples using writable. You won't see that on the exam. Then I can say browsable, and I'll set that to yes. Browsable is one of those words that always looks like it's spelled wrong. And then I'll say valid users equals, and for the valid users here, I'm going to lock this one down. I'm going to say deposit, comma, and then plus corp. All right. You list entries here separated by commas. But if it's a group, you put a plus sign before it. The plus sign says this is a group. So this will let me connect, and anyone who's a member of the corp group will be allowed to connect. Everybody else will be blocked. And once that's in place, that's my file share, assuming I haven't made a typo. And so I'm going to save that. And then I'll do I should do a test parm just to check for errors. No file errors, good. So I'll do a sudo systemctl restart smbd.service. And we'll let that one restart. If I get an error, I'll see it right there. It restarts. And so now I should be sharing that folder out. And I'm just going to do a real quick check. Sudo systemctl status smdb, just making sure that service is active and running, which it is. So right now I've shared out that folder and it should be available on the network.
So once we have all that configured, how can we go about testing just to make sure that it works?
All right, you're calling me out because I said it should be working. I did the IT guy thing and said it should be working, right? But who knows if it is or isn't.
Need confirmation.
Yeah. The easiest way to find out is to go to a client. Just go to a workstation, try and connect, right? That's the easiest way. We're going to do that in another episode. But in this episode, there are a few things you can do from the server just to see if it's working or not. We can try and connect. There's a few ways you can test status. There's a utility called SMB client that we can use. It's not installed by default. At least I don't think it is. Let's see. Nope, not installed by default. So I'm going to install it real quick. Sudo apt install SMB client. We don't normally need the SMB client on our server, so that's why it's not installed by default. But I'm installing it so I can do a quick test. And then we can test by saying SMB client -L, which says list all of the shares, and then we can point it at somebody. Now, normally you'd point this at a network server, but in my case, I'm going to point it at localhost. Give me a list of the shares here on my local host. And you can see I'm trying to connect as workgroup/dposit. I'm going to provide my password, which was password123. And there we go. It connects to the server. And what do I see? Well, I see my home directory because we chose to share out home directories. And I see the corporate folder right there, in addition to print and IPC. And notice those two, print and IPC, have a $sign by them. That means they're hidden shares. So those would be hidden normally to remote people. They could connect if they knew they were there, but otherwise they wouldn't see them in a listing. But I do see my other file shares, so it looks like things are good. And SMB is up and running.
And that was definitely good of us to just go in and make sure that everything was working, because even when it should be, we got to make sure. And in this episode, we were able to look at different things that you might want to share, sharing home directory, sharing printers, creating and sharing folders, and as Don just demonstrated, troubleshooting, just testing it all out to make sure that it works. But we're not done with Samba yet. We still have a little bit more to go, so don't go away. Thanks for joining us for this episode, and we'll see you next time.
Thank you for watching IT Pro TV.
Did you know Samba can actually use an existing Active Directory for authentication? In this episode, we'll show you how.
You're watching IT Pro TV.
Welcome back. I'm here with Don for more LPIC and more Samba, and this episode is all about integrating Samba with Microsoft Active Directory, right?
That is correct. Yeah, in this episode, we're going to continue our slight Microsoft crossover and talk about how we can integrate with Microsoft environments. We'll see how we can get Samba connected to an Active Directory so that it can use those for file share, authentication, and access. And we'll go over a few little extra things that we might need to configure, like user maps and special case scenarios. But by the end of the episode, our goal is to have Samba connected to an Active Directory for authentication.
Now, why would we use Microsoft's Active Directory as opposed to local Linux users or Open LDAP?
All right, well, all of those are options, right? So we could certainly use any of them. In fact, if you've got a Linux server, you definitely have Linux local users, so you could do that. And maybe you have an Open LDAP infrastructure in place already. You might choose to use that. But the reality is most enterprises, most businesses, even like medium, large businesses, they're going to have a Microsoft Active Directory already in place. And that's because Microsoft Windows is the most common desktop environment, and it gives them a few advantages, right? The Active Directory is not just a user database. It also lets them do group policy objects and security policies. There's various types of machine management that it can do. So there's a lot of bells and whistles that it has. If you're in a Windows environment, the Active Directory is great. If you're in an all Linux environment, though, you don't need Active Directory, right? You can just do Open LDAP, like Sophie said, or you can use your local accounts. Local accounts really only work if you have one server, right? If you have multiple servers, local user accounts are a pain, so you're going to want Open LDAP. But it's pretty rare you encounter an all Linux environment. And personally, if I was in an all Linux environment, I wouldn't bother connecting to Active Directory. I would just use Open LDAP and go that route, right? But if you've got Windows machines, you need to remember that Windows machines are designed to connect to Windows servers, and the Active Directory is directly integrated into that. That's the way to go. So now it's a matter of, can we take Samba and have it use the Active Directory? Can we get some of the advantages, get the best of both worlds, right? Get the user authentication and group policies and all that from Active Directory, but still manage our file shares over on a Linux server? And the short answer to that is yes, absolutely, we can do that. It takes a bit of work. It's not exactly the easiest thing on the planet to do, but once you have it in place, it works pretty well. It's kind of a neat thing and allows you to make use of those resources you already have. Now, the way this is done is through a system called SSSD, which is the System Security Services Daemon. And SSSD is designed to help us connect to really any security service, not just Active Directory. Active Directory happens to be built on Kerberos authentication, and so that's a standard, and we can leverage that to be able to connect and use it. Open LDAP is actually very similar, and we're going to have separate episodes just on Open LDAP. So that's a kind of a key piece of this. If you're searching around on the internet for documentation, you might find people mentioning something called WinBind or the WinBind daemon, so WinBind-D. WinBind-D is the old way of doing this. SSSD has replaced it, and so on the exam, you're only going to see SSSD, and in real life, you generally want to stay away from WinBind. That's the older way. SSSD is what we want to use. The configuration for it can be significant unless you already have an Active Directory in place. I've got the documentation from Ubuntu pulled up. They've actually got a really good article written on it. I'll put the link in the show notes. But it kind of runs through the various steps that are involved in getting all of this set up to connect to an Active Directory and go. But we can boil a lot of this down to just a handful of commands and get our system up and running with it. So it's not a gigantic nightmare. It just requires following proper processes. And if you miss any step along the way, well, that's when things tend to blow up. So hopefully that won't happen to us.
Hopefully. So is SSSD installed by default, or do we need to install it?
It's usually not installed. In fact, I think I've only encountered one distro that had it by default. So we usually have to add it. And that's because there's another security subsystem, the PAM system, that's built into Linux that handles most authentication by default. SSSD is extending that, so we're adding on. So we'll likely have to get it installed. But before we install it, there's a little bit of pre-work we need to do. If we're going to be joining an Active Directory, we need to be able to find it. Active Directory does some really weird DNS records. So whenever somebody deploys Microsoft Active Directory, they almost always deploy DNS servers alongside it. So in order for us to be able to do everything that we need to do, our Linux server needs to be using whatever DNS servers our Active Directory is expecting. So for example, here I'll take my Ubuntu server. So normally I would have its DNS pointing at like Google 8.8.8.8 or Cloudflare 1.1.1.1. But in my case, if I take a look at /etc/netplan /00, the installer config file, you'll see in here where I've overridden my DNS to point to my Active Directory's DNS server. A lot of people will configure their Active Directory domain controllers to be a DNS server. I need to point at that in order to find the Active Directory services. So that's the step one. Step two, reverse DNS doesn't really work very well under Linux, and reverse DNS just happens to be pretty important for Active Directory. So before you go to join up to an Active Directory, it's a good idea to hard code at least one domain controller in your hosts file. So to do that, I'm going to run sudo edit /etc/hosts. I'm going to open that file up, and you should just see localhost stuff, right? The loopback addresses, that kind of thing. I'm going to add another entry in here, and basically this is going to point to the domain controller that I'm going to be connecting to. So I'll just punch in here 10.222.0.52. That's my Windows Active Directory domain controller, and it has two names. So there's the NetBIOS name, which is just WinDC01, but then there's the fully qualified DNS name, which is windc01.lab.itpro.tv. My Active Directory domain, or realm, is called lab.itpro.tv. So the fully qualified name of that server is windc01.lab.itpro.tv. And by putting that here in my hosts file, that's going to ensure that my Linux box can find that domain controller and find the Active Directory. So I just need to get that put in there. Once that's done, I can save that file. And we don't have to reload anything. The host file is automatically read, so that's going to be in there. Then I need to install some tools. I've kind of got this, I end up doing this process a lot. So I've got a series of packages that I install by default. So I'll just do that here. I'm going to do sudo apt install sssd-ad. So I need the security system to connect to the Active Directory. So the sssd-ad package is one that I absolutely need. sssd-tools, which has some of the command line utilities that we'll use to work with it. realmd, which is what lets us connect to Kerberos Realms, which is what the Active Directory is based on. OpenLDAP is as well, so I would use that package there too. And then ADCLI, which gives us some Active Directory command line interface commands that we can execute to be able to manipulate the Active Directory. So those are packages that I kind of know are a guarantee. I'm going to need those packages. So when I run that, you'll see it's going to bring in a lot of other packages like SSSD-KRB5-common and KRB5 right here. That's Kerberos version 5, so that's really the authentication mechanism, and a handful of other packages. I'll just say yes to that, and we'll get those installed. Once that's done, we can do a quick check to make sure we've installed all the packages we need. One of the packages there we installed, the SSSD tools, that gives us a tool to look at a realm and identify what packages we need to connect to that realm. Well, I think I've already installed all the packages that are necessary, but now I can actually test to find out. We can run sudo realm-v, so I want some verbose output. I'm going to be doing discover, and then I'll punch in my Active Directory domain name. Remember I said my Active Directory domain was called lab.itpro.tv? This command right here it's not going to join me to the Active Directory, but it's going to look and see, can I find the domain controller? Can I find the Active Directory? Can I connect to the Active Directory? Does it look valid? Do I have all the packages installed that I need to have installed? So it's going to check all of that for me and give me some output. If I have any errors, I'll need to correct those before I move forward. No point even trying to join the domain until this command is happy. So when I run that, it's going to reach out and I can see it successfully discovered lab.itpro.tv. If yours does not find your Active Directory, 9 times out of 10, it's a DNS issue. DNS is really important to the Active Directory, and that's usually what will cause things to go off the rails. So check your DNS server, make sure you're pointed at the right one. After that, it gives me some basic information. It gives me the realm name, and this is important as well. Notice that the Active Directory domain name is all lowercase, but the realm name is all capital letters. Now, in Microsoft Windows, it's not case sensitive, doesn't matter. But in Linux, is case sensitive. And so when we're working with that domain, there's going to be times where we have to do it in capital letters and times where it's in lowercase letters. And I wish I could tell you right now, here's the pattern. But there's not a pattern. It's super annoying, and we just kind of have to memorize it. So just be aware of that. And then it lists the packages that we need. And I can see SSSD-tools, SSSD, some libraries, ADCLI. We've already installed all these. So we're good. But if we hadn't, I could go through and say, all right, these are the minimum, the 6 packages I need installed. So just to be on the safe side, I could do a sudo apt install sssd-tools. What else do we have here? Lib nss-sss. We got libpam-sss, adcli, and samba-common-bin. Those are the packages that I need the minimum. And so when I run that, all of them are already installed, so I'm good to go there. So now we've done all of the pre-work, and we're basically ready to get connected.
So now we're set up, but we still haven't actually joined the domain yet. Is that right?
That's right. And so that's kind of our next step. But if anything went wrong here, don't proceed, because it's just going to make things worse. Like, you actually do get to a point where things are so hosed up, you're better off just formatting your server.
Right.
We don't want to get there, right? But now I've got all good marks here. No errors. Everything looks fine. I'm ready to join. So now we're going to pull the trigger. I'll say sudo realm join. So I'm going to join a realm, and I have to provide a user account in that realm, in that Active Directory. Now, with the default permissions that Microsoft has set, any user in the Active Directory is allowed to join 10 computers to the domain. So if this is my first time doing it, I can use any valid user account in the Active Directory to join up, right? But once I hit 10 computers, that user account will stop working. But if I'm an administrator, I can join as many as I want. And so I really do need to provide an administrator account here. So I'm going to provide administrator. I'm going to use that main account at, and then the realm name. And here's where the case sensitivity comes in. This needs to be all capital letters. So I'm going to say lab.itpro.tv, which is kind of funny because with email and DNS, capital letters don't matter, but in this case, it absolutely does. Now, what's even more fun is the next thing I need to do is provide the domain name. And this time, it needs to be all lowercase, because why not? So we'll type that in. I'm saying use this user account, administrator at lab.itpro.tv, to connect to this domain, lab.itpro.tv. And the difference there is that with the username, we're talking about the realm, versus the last part, we're talking about the domain. And that's why up here, when I ran the command earlier, the realm name is capitalized and the domain name is lowercase, and that's why I'm having to enter it in that way down here. So I joke about it, but there is actually a little tiny bit of logic behind why they do that crazy stuff. Now, if something's going to go wrong, this is usually the part where it's going to happen. It's got to talk to the Active Directory domain controller. It's got to create the workstation account to basically serve as the machine account for this system and get things connected up. So when we run it, you'll need to watch for errors. Well, here's one sort of error. I need to provide a password. So this is the password for that Windows Administrator account. So I'll punch in what that is if I can remember it. And now it's going to connect to the server. And it's kind of anticlimactic. A lot of stuff happens in the background. If everything works right, you get zero feedback. It just drops you right back to the command prompt. If anything goes wrong, you'll get a lot of information on the screen as it tells you about what all went wrong and things that are broken. But once that's done, our Linux machine is now registered in the Active Directory. And so it's able to enumerate a list of user accounts. It can do what's called exploding groups. It can look at a group name and figure out who's a member inside of it, so exploding it out to the member list. So we are now connected to the Active Directory, and, well, honestly, it doesn't seem all that spectacular, does it? We're just kind of back at a command prompt. But we have now opened up a lot of new possibilities to the server.
So now that we are joined up, does Samba automatically start using domain authentication?
Not normally. So normally, Samba, by default, is looking at the local user database. And so we'll typically have to tell it to start using the Active Directory database. Not going to happen automatically, at least not from what I've seen. Fortunately, it's pretty easy to do that. So I'm going to jump into my Samba configuration. I'll do sudo edit /etc/samba/smb.conf. And we'll break that open. And what I'm going to do is look for my global configuration. So the global configuration, I'll just search for the word global right here. The global configuration is what applies to the entire Samba server. And looking at the various settings in here, some of these you may have already manipulated, like the workgroup name and so on. I'm going to ignore that because we're now connected to an Active Directory. And what I'm looking for is a setting called security. The security setting is what tells it who we're going to authenticate against. And so as I keep scrolling down here, you'll see where it's talking about authentication right here and the type of server it's going to be and so on. Right now, it's just a standalone server and so on. But as I keep scrolling down, eventually we'll get to the point where it defines its security. Now, it's usually commented out, so if I can't find it, I'm just going to add it myself and it'll be just fine. But you know, I didn't find it. Maybe it's not in here, so we'll just have to add it ourselves. I should have just done a search from the very beginning. So I'm going to look for security and see where that one turns up. That one is not it. That's it. So it is not in here. So I'm just going to add it myself. So I'm going to go back up to the top where we have the global section start. And I'll just add a note right in here at the very beginning. You know, we can add it in just about anywhere up here under global. And I'm going to say security equals, and then in all capital letters, ADS. Okay, and that stands for Active Directory Services. So I'm letting it know, hey, when Samba starts, take a look because we're connected to an Active Directory. And that's going to open its eyes. That's when Samba will realize, wait a minute, there's only a few local Linux users, but there might be hundreds or thousands of Active Directory users, and it's now going to rely on SSSD to help it find that, look at the list, and be able to authenticate. So I'm just going to save that, and now we're connected.
So that seems like it really wasn't so bad, but are there any sort of gotchas that people might run into, as you say, out in real life land?
You know, at this point, you might actually be fine. You might be done. Like everything is set up. You're now able to use Windows user accounts when you define valid users for connecting to a share and you're in business. But there is one problem you'll probably bump into sooner or later, which is Windows will allow users to have spaces in their names, and Linux will not. So that's a problem with name mappings. And so you might have to come in and define a name mapping for any users that have a space. The better practice is not to have spaces in usernames. I think that's what most people do. Even in the Active Directory, the GUI utilities won't let you do a space anymore, but the command line utilities will. So we need to make sure that we account for that anytime we run into that. Well, it's not so hard, but you do have to create a user map, which is kind of a pain to maintain. You have to go and update it anytime you do a new user account this way. But what we do is first I need to get back into my Samba configuration. So back into smb.conf, and back under the global settings, I'll just go right after that security note that I added a moment ago. So I'm going to add an entry in here that says username map equals, and I'm going to point to a file, and I'll put mine in /etc/samba/username.map. The name of the file doesn't matter. You can call it whatever you want. It just needs to be pointed to from here. All right. So I'm telling it, hey, we're going to maintain a username map, and it's going to be stored in this file. So then I'm going to edit that file. So let me just copy this so I don't have to type it twice. And so I will save my file. And now I'll do a sudo edit /etc/samba/username.map. It's a blank file because we just created it. But in here is where I would type on the left what would be the Linux name for a user, and on the right, the Windows name for the user. Now, hopefully they match. That makes life easy, right? And then off you go. But if there's a space, they can't match. So I might need to say something like, maybe on this side, it'll be user jdoe equals, and then in quotes, I would specify the name on the other side. So maybe it's John Doe, like that. And I put quotes on it so it knows that the space is a part of that name. Same thing if I did that for my own name, and so on. Now, in an Active Directory domain, this isn't really that much of a problem. So many people won't have to create a map like this. In a work group, this is a frequent problem that you run into quite a bit. But we're set up for an Active Directory domain now, so hopefully you don't have to do this. But once that's done, you can just save that file, get out of it, restart Samba, and now you're in business. You're connected to the Active Directory, and you can authenticate with the Active Directory accounts.
All right. And in this episode, we were able to look at Microsoft Active Directory, why we might want to use that as opposed to some other options. We were able to look at installing SSSD, joining to an Active Directory, and Don showed us how to enable AD authentication as well. But once again, we're not done with Samba. We've still got more for you, and I, for one, am very excited. So don't go away. We'll see you next time.
Thank you for watching IT Pro TV.
Are you on a Linux computer and need to connect to a Samba share? Stay tuned to learn how.
You're watching IT Pro TV.
Welcome back for more LPIC, more Samba. This episode is all about configuring a Samba client. So let's just go ahead and jump right in. What are we going to talk about today?
All right, we're going to learn about connecting to Samba shares, and we're actually kind of pulling double duty here because this applies to connecting to Microsoft Windows shared folders as well because they all use SMB. We're going to see 3 ways to do it: using the command line interface, using the graphical user interface, and using it where it automatically boots at boot time on our computers. All done within a Linux client environment and all getting us up and connected. So that's our plan.
So we're going to learn 3 different ways to connect to a Samba file share, but how do we know which one to use?
Pros and cons to each one. So certain benefits and detractors kind of depends on your environment. So let me run through each one. Command line interface. Command line interface is really useful if you just need to temporarily connect to a share, not something you're going to use a lot. Maybe you're trying to automate. So I want a script written and I want the script to connect to the share. Well, the command line interface is the easy way to do that for bash scripting. Also on headless servers. Maybe I'm on a server, I need to connect to a shared folder, and I don't have a graphical user interface. Then the command line is kind of our only option at that point. That's where we're going to use that type of connectivity. I mentioned the graphical user interface. Well, on a GUI, that's super easy if you're on a workstation, if you're on a desktop, if you're an end user and you're trying to connect. It's a heck of a lot easier than using the command line because we can use our file navigation tools or whatever to be able to connect to an SMB share, authenticate, and get connected. So that's usually where we'll see the GUI used. And then the last one is at boot time. If there's a shared folder that I access every single day and I always want to be connected to it, makes sense to set it up to connect at boot time. Or if I have a computer that's shared, used by more than one user, and I have one user log out, another user logs in, and I still want that share to be there, it's better to mount that at boot time because otherwise, like if I connect with my user account, when I log out, it disconnects. I wouldn't want that, so I could configure it to connect at boot time, and that would protect us there. So all kind of different ways that we can get it configured, and hopefully that lets you know which scenario is going to be right for what you're trying to do.
Well, so far we've been doing pretty much everything from the CLI, so why don't we go ahead and start there?
Yeah, and that's going to be pretty common for most of us when we're connecting because the CLI is what we know we're going to have. It's kind of the guaranteed method. So I'm going to do that right here. Actually, here, let me get out of my server and just get over to my laptop. There we go. So I'm on my laptop. And I want to connect up to the shared folders that we've been configuring these last several episodes, right? We created a corp folder and home folders and so on. I want to get connected. So I'm on my workstation. I want to get there. I may or may not have Samba installed by default. Now, I'm running Ubuntu 20.04 and I did the workstation install. It's almost a guarantee that Samba is already installed for me. But if you're ever not sure, you can install it. Now, we don't need the full Samba package to get connected. In fact, we just need the CIFS utils package to be able to get connected to resources from the command line. So I'm going to do a sudo apt install CIFS-utils. That's the package that I want, and I wouldn't be surprised if it was already installed. Actually, it was not installed, so it did install it for me. It's got it in there now, and that's going to give me the tools I need to get connected to Windows or Samba file shares. Now that I've got it, I need to create a mount point. So I'll say sudo make dir, and I'm going to make /mnt/corp. I'm going to connect to my corporate folder, and so that's what I'm going to connect to for this share to be able to work. Then I need to mount the folder to the CIFS share or to the Samba share. And this is going to be the long command, the command that does the real work for us. I need to say sudo mount -t, and I have to sudo this one because I'm doing the -t command. So anytime you combine that, you've got to be an administrator. And for the type, I'm going to say CIFS. Now, if I didn't install the CIFS utils package, this part is what's going to fail. That type won't exist. So CIFS util is what gave mount the CIFS type. Then I need to tell it the user that I'm going to be using. So I'll say -o user equals dpossett, comma, password equals, and I need to punch in my password. Mine, we know, is the highly secure password 123, so I'll punch that in. And then I have to add an odd option. So -o is actually options, and mainly you're providing the user and password as your options. But I need to add one more, which is no perm. And I'm not talking about my hairstyle. We're saying no permissions. Normally, Linux and Unix in general are going to be checking for file permissions. File permissions don't exactly work right when you connect to a Samba share. So Samba is doing its own permission checking, and that's what I want to rely on. So I'm telling the mount command and really the Linux kernel to ignore permissions here and let Samba do the job for it. If you leave that off, you'll connect, but you'll be read-only. Regardless of what the permissions are on the share, you'll be kind of locked in a read-only mode. You won't be able to write. So I'm going to do a no perm to make sure that my hair is nice and straight and that I'm able to write files. Then I need to tell it who I'm connecting to. Now, the syntax here is not the way we would normally point to like a Linux server. We're pointing to a Samba or Windows server. So we need to say // followed by the host name or IP address of that server. I'm going to use the IP address because I can't remember the host name of my server. So 10.222.0.51 / and the name of the folder we're connecting to. I'm connecting to corp, right? So that's where I want to connect. And then I need to tell it the mount point, which mine is /mnt/corp. All right. When I run that, that should connect. If I get an error, then I know I've got a problem I've got to sort out. But if I get no feedback, it should have connected. I'm going to double check that. I'm just going to run the mount command. So that'll list the mounts that I've got. And I do see there's the mount that we just added. And it's showing a lot of extra options that I didn't provide. Those are just kind of defaults that came in. But it is mounted. If I do a df-h, I can see that corporate folder right there is mounted, and it's even showing the available space. I've got about 8 gigs of storage available in it, and I can go and try and use it. If I go into /mnt/corp and take a look in there, well, it's empty. I could try and touch a file, so I'll just do test1.txt, and I'll pull up the listing, and there it is. I just created a text file. We could take like uname-a and echo that into test1.txt and then cat that, and there it is. So we're able to read and write into that folder. We're now connected to that Samba share. And so we got in. The main command that did all that was the mount command. That mount command is what's doing all the real work, telling the system it's a CIFS share. Here's the username and password. Here's the server to connect to, and then it connects up. Pretty easy process.
So I can see where that wouldn't really work for your average end user. So does using the GUI make it any easier?
It certainly can. And even, not just for end users, even for me, like if I just need to connect to a share real quick and I've got a graphical user interface, I'm going to use it. Command line's kind of a pain unless I'm automating, right? So if we're on a Linux workstation that has a GUI, almost all of them run the GNOME desktop environment, and it's got integrated right into its file explorer where we can just connect to SMB shares. Pretty easy. Let me show you how here. So I'm on Ubuntu 20.04, and I will bring up my file explorer, which I believe is actually called Nautilus in the back end. But I'm going to bring this up, and when we look at it, it's showing our local storage. You'll see things like your home folder, desktop, documents, and so on. So they're all kind of laid out there. But at the very bottom, you can click Other Locations. And right here, you can navigate your entire hard drive, or look, I've got an entry right here for Windows Network. I could browse for Windows servers that are on the network. Or if I know the server I want to connect to, I can just skip past the browsing part, and right down here at the bottom, I can type in the server I want to connect to. I'm going to do that. I'll just type smb://, so kind of like a web address. And then the IP or name of the server, I'll use the IP. 10.222.0.51 / and then the name of the folder I want to connect to. Mine is corp, and so I'll punch that in and I will hit connect. It's going to prompt me, am I connecting anonymously or am I using a registered user? Mine is a registered user. Deepazet is my username, and I'll punch in my SMB password, which was the highly secure password 123, and I'll go ahead and hit connect. And when I do, it connects up to that server, and right there I can see that test1.txt file that we wrote earlier. If I double click on that, it'll open up, and I can see that uname output that was on there. I could maybe create a new folder. This would be my test folder. So again, I'm able to read and write and do it all right from here. And not a difficult thing to do, right? Just punching in that server address, authenticating, and then there we go. So the GUI makes that a lot easier.
So if both of the examples that we've seen so far are temporary, that means that we're going to disconnect from those folders if we log out or if we reboot. Is that right?
Right. On the GUI side, definitely when we log out. On the CLI side, there's sometimes where it can hang around until a reboot, but usually when you log out, it's going to disconnect. If you're using tmux or other utilities like that, it might stay connected even after you log out. But if you reboot, they absolutely go away and they're gone. So if this is a share that I need all the time, I can configure my system to go ahead and mount it at boot. And we can do that by modifying the file system table stored in our system, right? The fstab file. So let me get back into my command prompt. And I'm going to get into /etc. And inside, or I don't have to be in this folder really, but inside of /etc, there's the fstab, or file system table file. So I'll do a sudo edit /etc/fstab. And this is showing the disks that get mounted when we boot up. All right. So I need to come through here and basically tell it that I want to mount to this Samba share every time that we boot. Now the problem here is going to be, you guys saw when we did the mount command a moment ago, I had to give it my password. Well, how do I give it my password in here if I want it to like not let other people find my password? The file system table has to be readable by the kernel when the system's booting up so it can mount the hard drives. Well, that means the file system table has to be stored unencrypted. And that's a problem. I don't want to put my password in an unencrypted file. So there's a way around this. If we're using LUX encryption and our disk is encrypted, everything gets encrypted except the boot folder, which is where the file system table will kind of end up being, so that's where our password will get compromised. So instead, I can put the password in my home directory and then call that from the file system table. And it will wait until after LUX has decrypted the disk before it does that mount, and that keeps my password secure. So before I go and put the entry in here, let me start out by storing my credentials in my home directory. I use my home directory because in theory, only I should have access to that. Administrators could have access too, but administrators can do whatever they want anyway, so there's no sense worrying about that. So I'm going to create a new file here, and I don't need to do sudo edit this time. I can just use nano, and I'm going to create a file called .smb credentials. You can call the file whatever you want, right? But this helps me remember this is for connecting to Samba, and it's going to store my credentials. Inside of that file, I just need 2 lines. User equals, followed by my username, and then password equals, followed by my password. In my case, password 123. So those are the credentials that we're going to be using to authenticate when we connect to that share. So let me go ahead and save that file. And now I can do a sudo edit /etc/fstab, and we can add a new entry in here and call that file to get our credentials. So to do that, we have to kind of type something a little bit on the long side. I need to do actually, I'm forgetting something. When the system runs and does mounts, it's doing it as root. And so the root user is going to be connecting to the share and connecting it to the mount point during the boot phase. And that means as my user account, I won't be able to access it. So I need to tell it not only to use my credentials with Samba, I need to tell it to use my credentials for creating the mount point as well. So there's a couple extra steps that I need to do here real quick just to make sure that we're going to be able to connect. One of those is when you look at your mount point. So I created /mnt/corp. When I look at that on the file system, I can see that the root user is the owner and has full access. Everybody else just has read and execute. That's going to include my user account. I won't be able to write to this folder based on these permissions. Now, when I mount it, I can tell it to ignore permissions, so that kind of fixes some of that. But there's going to be other issues with user access there. So, for example, when I start writing files, I don't want those files to be written as root. I want them to be written as me. But if I go into the corp folder and look, a lot of the files that have been written, oh, shoot, I've disconnected. So I don't see any files, but the files are getting written as the root user, not as me anyway. So I need to fix that, and I can fix both of these right in the fstab file. But in order to do that, I do need to do a couple of things. One, I'm going to change the mount point to be owned by me instead of root. So I'm going to say sudo chown. I'm going to change owner, dpossett:/dpossett /mnt/corp. That's going to make my user and my group the owner of that folder. Then I'm going to run the ID command to figure out what my ID is. I can see my user and group IDs are 1001. When you do a mount, you can tell it what user to mount the folder as. And so I can tell it to mount it as ID 1001, me, instead of mounting it as root. So now that I have that, I can say sudo edit /etc/fstab, and I can add my new entry down here at the bottom. Now, the entry is going to read like this. I need to point to the folder first. So mine is // and then the name or IP address of the server. Inside of the fstab file, I almost always use IP addresses because you don't necessarily know if DNS has been loaded yet at this point, right? So we want to make sure that it works. I'm going to do an IP if I can. So mine's 10.222.0.51/corp. That's the folder I want to connect to. Then I need to tell it where to mount to. In my case, /mnt/corp. That's the folder. Then I need to tell the file system. The file system in this case is CIFS, so it knows that it's a network share. Then the credentials. Now I'll say, really you'd put kind of any options here. So one of the options is going to be credentials equals, and I need to point to my credential file. And mine is in /home/dpossett/.smb credentials. That's that file we made a moment ago. Okay. And notice I'm not using // as the shortcut for my home directory. And that's because I'm not the one running this. The root user will run this, and home or tilde would point to /root, which is not right. So I need to do the full path. /home/dpossett/.smb credentials. Okay. Then beyond that, we can do a comma, UID equals 1001, comma, GID equals 1001. Don't mount this as root, mount it as dpossett, as me. And so that's my user ID and my group ID. They usually match, but they don't always. That's why I ran the ID command to make sure I had the right numbers. All right, then I'm going to do that comma and no perm again. We don't want permissions to be processed by mount or by the kernel. We want them processed by Samba, so throwing that in. Then the last two options, these are kind of important. You can specify, the first bit here is whether or not the dump command works on this partition. You never want to use the dump command with these shares, so this is always going to be a 0. And then the last one is, do you do a file system check at boot? This one needs to be a 0. If it's set to 1 and your system boots up and can't connect to the other server for some reason, then your system will fail to boot. We don't want that. If we can't connect to the server, we should just ignore it and let the system boot the rest of the way. A 0 lets us do that. So whenever you're mounting to a Samba share, you should always do 0, 0, not any other combination. But that's all it takes right there. I'm going to exit out of this file, and I will do a sudo mount-a, and that's going to tell it to go through and try and mount everything in the fstab file, just like it was booting up. And if I run the mount command again, I should see that it did connect. I see it right there. I see it's got the user identities. If I go into /mnt/corp and take a look, now I'm connected, and see how it's all tied to dpossett now, nice and neat. That's me, my users making these changes, and I can access the share. And every time I reboot, that share will be put right back.
And that's all there is to it. In this episode, we were able to look at 3 different ways to mount a Samba share. We looked at mounting from the CLI, from the GUI, and we looked at mounting at boot, or I think you have it in the notes as boot time, which I think is it's a cute way to say it. I like that. Mounting at boot time. And that's all we have for this episode, but don't go away. We've got more LPIC coming up, so we'll see you next time.
Thank you for watching IT Pro TV.